Welcome and thanks for joining us for this episode. Today we're going to be taking a closer look at some IPv4 address classes. And I know that there are, I think, a handful of classes that you and I have discussed before, but as far as the specifics, this is still very new to me. So, which as most of this stuff is, but that's why I'm here to learn with you. So let's start with talking about just the address ranges, because there's 5 different classes and each of them has their own range.
There is, yeah. And when this came out, INA, essentially what they did is, they made the IPv4 address blocks 32-bit space, and they said, all right, we're gonna divide this up based on the needs, what you need for the network. And actually, if I remember my history right, they kind of divided it up because they'd already had these large blocks of IP addresses allocated in the early days of the internet to these large companies. So they needed a way to kind of define that A block. I'll say what that means. But then everything else pretty much fell into this structuredized classful system. Now, some people might ask me today, well, if it's a classless system today and we don't follow the classes, why do we still need to know them? Well, you do need to know them because remember, you need to learn the language if you haven't been in networking before. And if I say, hey, I need you to do me a favor right now, I need you to assign me a Class C address with a Class B subnet mask. What does that mean? Well, we don't follow the classes anymore, right? Why do I need to know that? Well, that's why you need to know it right there, because you need to know that you need to prove that you're competent enough to speak the language back to somebody that understands networking. And that's just from a help desk role or a support role, right? What if you're answering questions in a well-lit room in front of a computer screen? These are absolutely questions that they loved to see. Why? They're easy questions to write, but I want you to know, you do some flashcards and you put these in, get these up here, they're also easy to get right. And that's why we're going to spend a little bit of time. This is flashcard material. I tell you also, I'm not going to bore you to death with the minutiae of it. I would encourage you to pause the video at your leisure when you need to take some flashcards, all right? Remember, if you just print out notes, you're not really committing them to memory. Create your own flashcards, and just the process of creating them, you're starting to commit stuff to memory. So that's my advice to you on this. This isn't the most glorious topic. We would always like to get in there and configure the network switches and connect them all, but this is more of the elementary foundational stuff that we just need to know.
And because this is flashcard material, we've got, I think, like basically a table that's got all these numbers in it. And like Wes said, you can pause and take notes when you need to, because it is something that, you're right, it's so easy to write a question like that, but harder to memorize and answer. So do you want to start with what these different classes are used for, how many networks they can support, the actual ranges? Where do you want to start?
So what I think I'm going to do is I'm going to start with just identifying what the classes are before we even talk about their attributes,
Gotcha.
Right? So let's go ahead and let's dive into that, because I've got this set up in a way to also help you remember how to identify the classes instantly in binary, just by the very first octet. So exam-worthy material. So you have, Sophie had already mentioned, you have 5 classes. You have A through E. I want you to know the ones that we allocate from are A, B, and C. D and E, we do not use as host addresses. I'll get back to that. But if you look at a Class A address in binary, the very highest order bits, what do we mean? The leftmost bits. When we talk about IP addressing, the highest order bits, the ones that take precedence, are the ones that are to the left in binary. The very first 2 bits in any Class A address is going to be 0, 1. I don't care what's behind it. 0, 1 can be 8, what would that be, 6, whatever the 6 bits are behind it. Right away, I can identify it's Class A. I don't have to do any binary conversion. I can see it right away. Class B. Class B is a 1, 0. I don't care what's behind it. Has to have that 0, though. A binary 1 and a binary 0, right? And the better you get at your binary, you can see that value right there is 128. I could tell right away. It's 128. All right? Because I know 0, 1, and then all zeros in 8 bits is 128. All right? Or a 1 and then all zeros behind it. Excuse me. Class C. Now we have 3 bits that are reserved for the Class C, right? It's 110. I can look right away, and if I see a 110 and then all ones or a 0001 after that, I know that it's going to be a Class C. Same thing with Class D and Class E. Know that these bits were reserved to define the classes. That's how initially, because think about it, we don't really talk in computer language, right, which is binary. We see the human readable format, which is decimal. But that's kind of the binary behind it, which is what they're actually using. So I wanted to go ahead and I wanted to start there. Now, the next thing I think what we're going to do is we're going to kind of switch over and we're going to talk about the ranges now. You want to go ahead and do that, Sophia? Does that sound good? Because we got a lot to talk about. We really do.
Start with that and then talk about what they're used for maybe later.
That sounds great. Okay. We'll do exactly, keep me honest though, we'll do exactly that. All right, so the ranges here, I want you to know, pause the video. We're not going to take the time to read all of them to you. All right. You can see this covers the entire 4.3 billion address range from 1 to all 255s, right? Notice Class A, I'm going to genericize it 1 to 126. If you look at that first octet, in binary, anything between 1 and 126 will always start with a 0, 1 in binary. That's how you can remember these little quick things that you can get to the answer really quick and move on and get to the more complex answers that you might have to spend a little more time on. All right, 128 to 191 for Class B, 192 to 223 for Class C, 224 to 239 for Class D, and then finally 240 to 245 for your Class E range. Now, that is some of the things that we need to know about the ranges. But we're not done. God, I sound like that old Billy. What? Wait, there's more.
Oh, Billy Mays?
Billy Mays, yeah. So they also have default subnet masks. I want you to understand in saying this that at the time this was a classful system, these were the boundaries. There wasn't any manipulation. You fell within a Class B range, you had a 255.255.0.0 subnet mask. We don't follow the classful systems anymore. The classful system, we don't have these boundaries, but they are still way markers for the classes in discussion. Again, think about it. I got a Class C address with a Class B subnet mask. Well, you need to know what those are, right? So your default subnet mask for A, B, and C, we start with 1 octet of 255. B is 2 octets of 255. Or you can say 16 1 bits in the subnet mask. I've also got the CIDR notation here. That's how many bits are actually in the mask. And then you have Class C has got 255.255.255.0. That's 24 bits. Notice something about the multicast. I gave the cat out of the bag, right?
Well,
the Class D and Class E.
Yeah, those last two, there's no default subnet mask. Is there a reason for that?
Yes, they're not assigned as host addresses. All right, I'm going to go ahead and I'm going to I already kind of did let the cat out of the bag. The Class D range is what we call the multicast range. And this is set up for multicast communications. If you have been following along with Sophia and I, remember a multicast communication is one to a specific group. All right. This range is how your computer's set up and connectivity devices set up those multicast groups. You do not have an assigned subnet, and all hosts will use these addresses. The Class E range, same thing. I'm going to go ahead and tell you what the purpose is for it because it stands out here like D, like an oddball with no subnet mask. What does that mean? It's an experimental range. It was set up in the early days for future use, including the development of additional protocols. We do not assign it as host addresses, and that's why there's no subnet mask.
Okay.
So these are some of the things that we need to think about for sure.
Okay, gotcha. But as far as the other ones go, they've got the default subnet mask, and they can support a certain number of networks and hosts, right?
They certainly can, and this is where a lot of that flashcard material comes in. We were kind of talking about it. I'm going to kind of go off the beaten path here for a second. Sophia and I were talking, I'm rattling off some binary numbers and stuff, and she's kind of looking at me like, wow, you got to know that stuff? Well, it's just because once you get used to seeing the binary, I've taught entry-level exams where you had to know resolution types too. And if I look at 24-bit resolution, that gives me a possibility of 16,777,216 colors. That's 24-bit color. If you remember that 16-bit color is 65,536 colors, and that 8-bit color is 256 colors because 0 counts, you now know what the potential hosts are in every one of these networks. Let me show you what I mean. All right. So the networks are the portion of the subnet mask that is determined to be, that defines the network size. So in 8 bits, all right, minus 2. Keep in mind, too, some people get confused as to where these numbers come. They say, hey, Wes, I know 2 to the power of 8 is 256. Why do you have 128? Well, that's because the highest order bits, they're reserved. I'm not doing 2 to the power of 8. I'm doing 2 to the power of 6. Right? A little bit different. All right. So again, these bits here are all reserved. And that's where some of these numbers get funky, because you would say, okay, we've got 24 bits in the subnet mask. That means I should have 16,777,000, what I just said, right? Well, that's not true. 3 of the bits are reserved. All right. So it's actually 2 to the power of 21, which is 2,097,153. That's how these numbers aren't so obvious. The next numbers, the next ones I show you, will all fall in line with the resolutions. Like I was telling you, makes it a lot easier. Where do these numbers come from? Well, these numbers are powers, 2 to the power of, 255. But remember, you have 2 bits in there, so that's not all 8 bits. And that's why they're a little bit different here. So what do you need to know for this as far as the networks? Know how many networks they are. I also want you to know the hosts. Now, the hosts should start making sense when we talk about, like I said, the color capabilities of monitors and the 24-bit color, right? Well, notice 000 in the host portion, right? These are octets. So that's 24 bits reserved for just host. 2 to the power of 24. 16,777,216. You say, well, Wes, you can't count. You get 214 there. Yeah, that's right. But in a network, I can't use the network ID, nor can I use the broadcast. Minus 2 gives you this number. All right.
That's a lot of hosts, though. 16 million?
Absolutely. You know what? That is a great spot to stop and go ahead and mention. I'm going to go ahead and jump ahead, and let's go ahead. Who would need something like that based on that comment, right? Large corporations. In fact, in those early days when we only had about 5 or 6 entities connected to the internet, there was the forward thinking. I think it was Ford. I think I said GM in another episode. I think it was Ford. Ford had a forward thinking when the internet was ARPANET and stuff was coming out, that they wanted an IP address for every one of the cars that they would manufacture in the future, right? So they reserved millions and millions. I think they still have it too, but they're not using it. That was then, this is now, right? So companies like that need massive amounts of nodes, global companies that would need that, they would use these type of networks, these type of IP address ranges, right? Large data centers, all right, that are just have hundreds and hundreds of thousands of endpoints potentially, all right? But now let's go to the B range. I zoomed out a little bit too much. I still want you to be able to see this, right? Default mask, 16 bits, 16 bits for the host. All right, 32 bits, right in half. 2 to the power of 16, 65,536. Minus 2, 534, right? Also, by the way, did you know that our port values are 0 to 65,536? It's all based on a 16-bit value, right? So you start to see these numbers more and often because you're dealing with computers, and that's what they talk in. They talk in binary. All right. So back to your question, not quite as, I love this word, gargantuan as the 16 million. That's still a lot of networks, or a lot of nodes on the network, almost 70,000. All right. And then the last one is ones used for more small offices versus the first two, which are going to be bigger corporations and data centers. The last one's 254 nodes, right? So if you only had 254 nodes, well, guess what? That's the one you want. But what if you had 1,000? Well, if I got a 65,534 based address, I would have 64,000 addresses that are wasted. So now what I have to do is I have to get 2 Class A or 2 Class Cs, maybe 3, right, to actually make those 1,100 nodes. And that's what ultimately this classful system became so wasteful. All right. Sophia's corporation comes to me, and let's say that I'm one of the regional internet registrars who are helping to allocate these IP addresses. She comes to me and says, hey, I have a network that needs 15,000 nodes, right? Hey, it's still a big company, not too big, but it's big. I mean, it's decent size enough. Well, how is she going to do this? If she gets a 65,534 host capable network, she has now wasted 60,000. Did I say 15? I can't remember what I said. Like 15,000, she's wasted 60,000 addresses. She didn't want to do that. So now what does she do? Well, now she's got to get 5 Class C addresses to be able to support that scalability. And you can see why we started losing some. In fact, there became such a scarcity it's about 10 years now, that when a Canadian business went out of, when a Canadian company went out of business, they were sitting on an allocation of about 500,000 IP addresses, and they were going to try to sell them to Microsoft. ICANN steps in and says, you can't buy those. Those are allocated from us. They can't sell those to you, and they become back allocated in the pool. So this is a very wasteful type of system, but you need to know it. And then I just kind of put the last ones here for your benefit. Remember, this range is all multicast. This range down here is all experimental research and future development.
Now, you kind of alluded to, when you were talking about that big 16 million host possibility, you kind of mentioned like, oh, that would have to be like a huge business, a huge corporation, maybe like an ISP, something like that. What about these other classes, especially class B and C? What would be some real world examples of organizations that would use those?
Okay, so kind of building off of, thank you for letting me use you as a corporation and an example. So back to that, that's one of the things. So medium size, like a university. I'm not sure the size of the camp. I know UF has got campuses everywhere, but I don't know how it's about 20,000, 22,000 students or so. Let's say just generically, or how many?
Probably at least double that.
Okay, double that.
Yeah.
See, it shows you what I know, right? Well, if UF needed that many nodes, they would have to make a decision. They wouldn't do, I don't think they would do it this way, but do we allocate or ask for multiple C range allocations to match that scale, or do we go ahead and go with a class B, right? So you'll see things like large organizations with a vast number of IP addresses might be using the 10 dot, or not the 10 dot, that's private, the public A, the class A. Medium businesses, class B. Small businesses, very small businesses are probably going to use class C. Keep in mind that class D is just going to be used for multicast groups and experimental purposes on Class D. The only IP address that I realize that we use in this range, some of you that are maybe astute students say, well, what about that all 255 address? Yeah, that is technically used. That's called the local broadcast. So when a DHCP server comes, or actually when a DHCP client comes online, it doesn't have an address. It sends out a broadcast message at layer 2, which is to all Fs. That maps to the layer 3 broadcast of all 255s. And that means the DHCP server is going to receive it. Oh, yeah, I heard you. Yeah, well, everybody heard you. Don't yell so loud. I heard you. I've got an IP address. Here's your package, right? So you do see that the 255, all 255s is used. It has a special use case. It's not allocated to hosts.
Okay, and then the multicast group, that would be like streaming services?
IGMP, Internet Group Management Protocol, Message Protocol. That is the protocol that handles multicast communication. So for instance, there are things like you have a group of Apple computers, all right? They're only supporting Bonjour, right? Well, they can start a multicast group. I don't need Windows getting involved. The only ones that can actually use this technology. So you will have specific technologies that will build in the application stack and create multicast groups to do certain network things. An example of that is something like Bonjour, where it uses multicast communications to talk to other Macs and Apple devices on a network. They're using multicast because if they use broadcast, it would be chewing up our bandwidth and causing unnecessary communication. So a lot of smart software developers use multicast because it's more efficient and it's more network friendly, if you will, as far as bandwidth goes.
Sure. Okay. Yeah, that makes sense. So we kind of went through each of these groups and talked about what the common uses would be for each IPv4 class and kind of some real world examples of that. But I know there are also some like special use IP addresses. What are those used for?
There are quite a few of them. There are some that you probably didn't see in this range. In fact, let me go ahead and just move. Do you see here, and I'll zoom in a little bit here. Do you see here in the range for the Class A, Sophia, that we have 1 to 126? Mm-hmm. And then notice what happens. We go from 126 to 128.
Right, we jump over to 127.
What happened to 127? Now, some of you that have been in networking might know and heard of a loopback address, 127.0.0.1, right? We ping that. That whole entire network is actually reserved. That's why you don't see the 127 at all in the public IP address ranges, because INA, and yes, there's an RFC. RFCs are really good for testable material. RFCs are good for Googling after that. So I'm just being honest with you. So RFC 1690 says that the loopback network is 127.0.0.1, or excuse me, 127.0.0.0 with an 8-bit subnet mask. All zeros is for local use, local identification. So for instance, you can have a server that is broadcast or that has an all zero address and it's binding all of its network adapters to that one address. Send everything to this, right? Companies use it different. Routing will use that as the default route. Send that when you don't know where to send it, right? That's the default route. That is also reserved. Notice that it starts at 1.0.0.0 and it doesn't start at 0.0 because in binary 0 counts. So where'd it go? It's reserved. Last but not least, there are other ones too that I didn't put in this one that if you're just starting out in networking, I don't think you really need to know. Like there's an entire 100 dot range that is used only by ISPs to do routing through ISPs. It's still in the list, but you can't use it. It's reserved. 169.254.0.0, and I mean those last two octets can be anything up to 255.254. That is what's known as the IPv4 range. All right, the IPv4 range is the automatic private IP addressing range, and this is used to basically have computers generate in a zero config manner with no configuration their own IP address and be able to communicate. However, it cannot have a default gateway, so it's not routable. And we typically use this as a fallback when we cannot communicate with a DHCP server. It was actually started back in Windows 98 as a way to generate IP addresses and maintain communications without the presence of a DHCP server. Now we use it as a sign of something's wrong with the DHCP server because we can't find it or we can't communicate with it. So anytime you see that, that's an IPv4 network. The big thing about that is it has a 16-bit subnet mask. You cannot change it, and you cannot say configure it with a default default gateway. So we can't route traffic off of the local network. These are some of the special ones. There are other ones out there, but these are the main ones that you're going to see probably almost on a daily basis.
Definitely a lot of numbers in this episode, whether it's qualitative, like those IP addresses where there's a specific value, or these quantitative numbers where it's upwards of 16 million hosts that could be, for one of these Class A businesses. So I'm glad we got to go over all this. But again, you may want to go back, rewatch, pause where you need to, take some notes for your flashcards, because something tells me that you might need it. Thank you for walking us through this, Wes, and breaking it down for us, because this is a lot of information. And thank you for joining us for this episode, and we'll see you next time.